Thank you, Jorge.
Okay. Welcome. Okay. Uh, First of all, to acknowledge to the committee for this invitation to talk today. In this talk, I'm going to talk about semantic clarity and the problems that we have experienced during the last 20 years that we have been dealing with different knowledge organization systems during this period, just to gain insights of what is the best approaches or the most promising approaches that we can take in the future. Next. Well, as you know, conceptual clarifications have to do with analyzing and refining and aligning concepts. In our case, our goal is transdisciplinarity. To achieve this goal, we have to do some things from the first layers, these foundational layers that is about information clarity. We need to start with this goal with well-structured and clear information and reliable. If we don't have this, it's impossible to connect different disciplines. Next, we need some way to achieve this interoperability. To do that, we need shared meanings, same serialization, the same way to code the knowledge, and common standards as well. If we have good data, interoperability ways to do the things, we can go a step beyond to reusability. Reusability is managed data to reuse in another context. And the last one is the transdisciplinarity. That is knowledge integration between different domains. Here, we usually talk about FAIR principles that are fungible information, accessible information, interoperable, and reusable. And next, we need some epistemic compatibility to achieve this transdisciplinarity, because if we don't have common elements between the discipline, is impossible. We need some semantic agreement before doing that. I don't know. Yeah. Why I need to have this because to I can have this. Yeah, I suppose there is. Okay, let's see an example, a small example. You know that to have reliable information, we need some sources that support this information. But there are many papers that start with some sentence like, in this paper, we are understand this concept with this meaning, and they change the meaning. If they change the meaning, it's impossible to say that they are supporting this clarification, this meaning. We can see that, for instance, here, if about sustainability, everybody are using sustainability, but with different meanings and very different meanings. It started with a United Nations that said that is something that in meeting the needs of the present without compromising the ability of future generation to meet their own needs. It's very ambiguous. So the result is that every paper defined in a different way. We have here one that say that this is a process of negotiation. Or we have here another that say this is as stakeholder satisfaction and view various ESG criteria. Are strange. If they change the meaning, these papers are not supporting the facts that we want to support with the to achieve this the multidisciplinary. There are many problems. There are some of them that are neurocognitive, are other that have to do with the linguistic nature of because to convey information we need words, and linguistics have problem. Everybody knows this problem with synonyms, polysemy, and ambiguity. We have many solutions, like with thesaurian ontology, and we are going to see this. And in the implementation level, we have problems with interoperability, lack of consensus, and scalability. First one is neuroconnective dimensions. What happened? Well, we need that the cognitive load for our brain to be small. If someone, for instance, have a conflicting idea with our mindset, I'm going to reject this idea. Why? Because for me, it's more cognitive cost to accept the ideas of the opponent that keep my own ideas. So this is why people don't never change their mindset. It's nothing because I born in this way. No, it's not that. It's because for my brain, it's a cost. And energy is all in the body. The 20% of the energy in the body is the brain. So we have to save this energy some way. And they had problems later with all this interoperability of concepts because we are not going to, I don't like this concept. All my life, I say this term, and this is enough. If I have to change the meaning, I change the meaning, but I don't going to accept this new meaning of sustainability because it's a cost. Well, so we have problems for this cognitive load to have this cognitive load low, like simplification versus complexity. Life is complex. Simplification is a loss of information, but to learn, we need some simple view of the reality. But this simple view is something that hasn't had all the information in it. Abstraction is harder. Concreteness, we love to learn with examples, with distance, not with abstract concepts that are so difficult to understand. The cost, in this case, is very high. Divergence versus normalization. People try to speak in the same way that the people who is talking every day. If they have a vocabulary, we are going to use the vocabulary of our family, of our friends, but no, the vocabulary of other. I see all the time now because I try to speak all the time in Spanish because I'm used to speaking Spanish all the day. So because my cognitive load is higher when it changes the language, when they change the domain, when they accept other domains. There is, of course, there are another things like the environmental, of course, like this idea that we have heard of all our lives with the Inuit have many names for the types of snow. And, well, this is okay as well. But the main problem are these. Look at this simplification. If we want to build a house, we are going to have an architectural floor plan, a plumbing plan, a foundation plan, an electrical plan, a heating plan, an isolation plan. We are going to have many plans, but they are good to understand how my house has been built. But this is not my house. My house is that. And I have a tree. Here, there is no tree at all. I want to know what is going to happen if this tree grows and grows. What happened with the light? I have enough light in this room when the tree grows, or we have a problem with the roots of this tree, because maybe my foundation plan is not good. It's not. I have to reinforce this part, or I don't know, or to nail to hang a picture in the wall. I have to know if we are going to pierce some electric cable or some pipe. Simplification is good, but the complexity is necessary. We can't have a good form, a solution if we don't consider the whole. So we have a problem there because our brain rejects complexity. So we have to accept this complexity. So we have different ways to do that. Some the more trivial, we see that in the school, the water cycle. We have this water cycle in our book, in the scholar book, all our life. This is very simple and it's very easy to follow. Well, this works because it's a very simple system in words. I don't know. Maybe for some in some grades is so complex, but it's the scalability is very low. We need some solution that is scalable. The reuse is very low, so it is not a good approach to achieve transdisciplinarity. Difficult. Entity relationship model. You know this in database. This is richer in information that the conceptual map. We have here relation, not only this concept, but we have properties, we have relationships, we have some hierarchies. No, it's very frequent, but we have cardinality. How many elements in this class are related with this class? The problem, the same, is a solution for a database, just a one database. We can move this solution to other domains. Well, indeed, they have to done because there is a representation that is RDF that said everything in the world can be represented with a triple, subject, attribute, value, system. But it has a problem. If you go to the relational system and you can do any query, just a join. The code you need in SQL is this size. With my own schema, is this size. So the complexity is going to be later. No, but I can avoid this complexity in the system. And we have class diagrams in UML. This is used to design programs in software, and the problem again is the same, because this diagram are for one application, one case. we can reuse that. My director supervisor in my dissertation thesis was working, trying to reuse these diagrams for 20 years. I think it's not successful at all, but he have do a collection of millions of diagrams, and it's a good approach. It's something like ChatGPT, but with diagrams. But it's difficult to reuse this. You only can reuse some parts. For instance, a person is going to have always a name, always is going to have a birth date, a place of birth. Yes, there is some part that are reusable, but not all. But we here have something that is very good, that is polymorphism. In inheritance classes, that we have here more things, but it's not enough. But as I said, the solution, the theory for many years with Frakes, with Ruben Prieto, they always said, if you go, this is the cycle of the life cycle of software project. If you use the requirements is the first part, is what have to do my software project. They say, the theory said, if you have requirements well defined, you are going to be able to reuse all the system to program new software automatically. Well, this is the theory. I think it's not working at all. Well, in some parts it's worked, but it's not so a successful approach that the one that we know now, that is to reuse frameworks and libraries. The first thing you do in Python, import, because there are 500,000, 500,000 libraries out there. 500,000 is a lot. It's not only, it's not a module. It's not just a function. Functions are in modules. Modules are in libraries, and libraries are in frameworks. And we are using frameworks, reusing frameworks. This is the way to collect the bricks to build the wall. It's impossible to do. Well, I can see ways to do in other way. Well, hierarchies. Hierarchies is a way to deal with complexity. Why? Because we have 500 concepts. We can maybe classify this concept in 20 concepts, and we can reclassify this concept in 5 concepts. And it's easier to read 5 concepts than to read hundreds of concepts. So it seems that it's a good way, and indeed, taxonomies are everywhere. Taxonomies are 2-layer, usually, a 2-layer system. In this case, we have the concept and we have a generic term. But it's not enough. The information here is very low, so we have another way to do things like this, thesaurus. We have been working to build automatic thesaurus during 20 years, and we have some successful projects. Other are so failed projects. There were everything there, but we have here more information. We have hierarchies. We can deal with against these synonyms. That this is a problem. How? Well, we say you only can use this term. It's not never is going to be in this domain synonymous. If you want to use this term, you have to use this other term. It's like this. If you want to use car, auto, you can't. You have to use car. And you have to use motorbike, not bike, because bike is maybe it's a bicycle, maybe it's a motorbike. You don't know. So there is related terms like motor vehicle with road. There is some aggregation of hierarchies like car with a whole part relationships and these things. And there is a way to represent this with discuss in digital. So it's a good way, and we can do some things. Well, there are many thesaurus. There is a collection in medicine. We have been working for 10 years in control vocabularies in medicine. And there is one of them that is called MESH, the medical subject headings. Medical subject headings is indexing, is every term in the Medline database. Medline database is a collection of 15 million of papers. All of them are described with these MESH terms. And they do that manually for 60 years. So it's great. There is another one that is WordNet that is very interesting. There is a tool that is Tema3 that I think is from an Argentinian, yeah, and this is very good. This system. And well, I said there is not attributes in thesaurus, but there is something similar that is called faceted thesaurus. In this faceted thesaurus, we describe the same object with different views. For instance, in biology, we can say phenomenon, processes, organization. Imagine something in a museum. Well, we can have different facets, but the ones that works better are the ones that people in journalism use. If you can describe something with what, where, who, how, who, it's going to work. Because if you use always the same hierarchy, the way to merge different hierarchies is easier. If everybody use different hierarchies, it's going to be harder to relate all these things. Well, we can see how we can use to relate different. I said that the thesaurus have a problem. Usually it's only for a single domain, but this is not written in the table. You can do other things. For instance, there is a problem when you try to build a multilingual thesaurus. For instance, imagine you have two languages, and there is going to be some concepts that have a partial equivalence. Maybe it's only part or this part only, or there are some cases that there is equivalence from single terms to several names in the other language, or there is no equivalence. What you do when you have this in a domain? What you do when you have partial or inexact equivalences? We can see some examples. Well, I don't know German at all, so maybe you see, well, how is this not working? But okay. But this example are in the standard, so I think that they make sense. They say the Wissenschaft is not exactly the same that science. So we need another term. in the standard said, well, you have to borrow from the German the concept and the term to represent it. And later you have a narrower term from Wissenschaft that is science. They say that. Again, I don't know well, what does mean. In this case, there is a term that have different ways to express. For instance, in English, well, in Spanish, we can translate with carburante and combustible, and it's not exactly the same between them. So it depends when how you have to translate well to the other languages. Just kidding. I don't know. I trust in the standard that it said that is not the equivalence is to Russian and Lutheran. Well, equivalence of one term to several in the other languages. Well, in this case, they said that French too is like lips, but maybe it's different. I don't know what used for. That there is a preferred term, a preferred way to say a concept and a synonym. In this case, they said you have to use French too instead of suk. That is different. Yes, they said that. It makes sense. I don't know. Well, but there are terms without equivalences. For instance, we don't have this term that are children that are alone at home. I can imagine to have a word to say that, but with a sentence, we have to use a sentence to say that. They said not, but in German there are a way to say that. Well, the thesaurus is all, but for me, it's strange that a concept so complex have a term. Well, there were another approach with the theory that was done by a project called WordNet. WordNet in the 90s and the 2000s was pervasive in many projects. It was to try to create a thesaurus with all the English words in English. They said, well, maybe we can use this tool to translate to other languages. And the first, there were many projects that only use WordNet. Now it doesn't make sense with the large language models. But anyway, they said something that was an interesting idea. They said, in a dictionary, we have entries and we have definition. What happens if we do the things in the other way? We have definition and many entries that are equivalent synonyms of this term. The idea, they said, what? It's not going to happen anything with, well, they said that this was called synset, set of synonyms. And this set of synonyms have hierarchies, have whole part relationships, have attributes, and these things. So he said, the best way to translate a language to other is not with the terms. It's not to say this word means this in this language. The contrary. He said, No, this concept in this language is this. The same concept in this language is that. It's a different way to do things. They call this the interlingua, and they connect all the languages with that. And they say, if we do the things in this way, we can reuse the domain ontology and the top ontology, because the synset have relationship between them. And this is easier to do that making a domain ontology in Spanish, another domain ontology in Italian. They reuse the definition, don't reuse the terms in one domain. Well, this is, as I said at the beginning, the first thing that we need is that the text is clear. If the text is not clear, it's impossible to have a good result. It's important to know that clear text doesn't mean a text with few words. We have here, for instance, original text for genetic or something like that. Yes, genetics. This is the original text. This is a simplified version. Simplified version, always we have information loss, and this is the clear one. The clear one have a notation that every time that I say, for instance, genetic factor, the characteristics they inherit from their parents, I have to clarify all the time. So this is why clarification and clear text are so close. Many times we have a project that for associated with clear text, and indeed we are talking about clarification all the time in some way. Well, there is a challenge with the web. Why? Because thesaurus works very well when we have only a discipline, one good discipline. But what happened on the web? There are so many disciplines. Everybody's talking about a different topic. There is nobody that said, no, the good term to use, if you are in this discipline, you have to use this term. And you can convince to talking to all the population in the world that are creating a web page to use your own words. It's impossible. It's crazy. So we have another approach, for instance, to know what is the more reliable information, the more interesting information, the more clear information. The first steps 25 years ago was Google, when they said, well, we are going to go with a voting system. If you have a link to my web page and he has a link to my web page is better than your page because we have 2 votes and you don't have my votes. So this is a good way to do the things, and Google use another approach. You say, hey, you have to be minimalistic in the interface. At the end of the 90s, there were some web pages that were crazy, like Alta Vista and this thing that was crazy, so overcrowded, and Google was the piece. It was white and only a search box. No, and the filter was difficult to find. There is another way to do the things like that is linked data. Linked data is, well, the web is crazy. We don't know how to trust in the concepts. Maybe we can do the other things to convert all the web in a database. Look at this. We have Paris, the concept Paris. Well, everybody understands the concept Paris, but it's not so clear. What does mean Paris? Is the son of Prime in the war of Troy? Is family is Paris Hilton, or is one of the Paris that only in the United States, there are 53 cities that are Paris. So it's not so easy to know what is Paris when you are on the web. You have to describe in some way to this ambiguity, to reject this ambiguity. How? Well, the person who create the web thing that we proposed that it was we can do that by the identity. The identity is said, well, in this web page, like in the Merriam-Webster said that this concept means that. But instead of that, they said, in this web page, say that title means this. And we can go to every time I use this concept, I said, I'm using this concept with this as defined in this place. This is identity. And we need a URI. Well, we have to be able to reach to this web page with a protocol that is pervasive, that is the BPS. We have a language that is RDF and a retrieval language that is Spark, and navigation through links. As I said, RDF, subject, predicate, and value. This web page, the predicate is, the author is John. And this is easier if everybody use this in the same way, the codified in the same way, the information is easier to merge the information later. To merge information, we have the same serialization, the same codification, the same knowledge model. And there are some places that have this element, these properties like author, like this predicate, and the value that these terms can have. The problem is that, as I said before, people have a tendency to diversify. Another tendency is to standardize. If you see the Carloman, Empire, they have France and Germany and many other places like the north of Italy, and they speak more or less in the same language. But 100 years after Carloman, there is not the same language anymore. So people try to diversify the way they speak. We have Latin in Spain, and after the Roman Empire falls, in 200 years, we have 5 or 6 languages instead of the one we have. And later we are borrowing terms from the other languages, so we have a standardization process again. Diversification first, standardization next, because we need to convey information. And next is always diversification. Teenagers have this only in your life, you feel these tendencies. And this happened with these vocabularies on the web. They said, for instance, for birthday, you say birthday is very easy to understand this concept, but in different vocabularies, it's defined in different way. And it's very similar, the meaning, but it's not the same. The problem is that it's not the same. This cause, well, but these vocabularies are 500,000 and million of triplets on the web. There is only, it said that there is 150 billions of triples. In 2020, there are many concepts. And this has been used to discover new information. If we have many relationships, We can discover with software new information. There is something that is very funny, because this person, Francisco Sanchez, I never heard in philosophy, this person. But we discovered this because there were many relationships that they found in many books from Descartes, from Voltaire, that used to say, and one, as said this person, and they said, well, in Spain, nobody knows this person. And but he said that it's important. You can discover new information with these relationships. And this is one of the goals, to do science with this clarification that you have done before. The problem is always the same. At the beginning, as I said, we have the dictionaries. We have dictionaries. Well, dictionaries, maybe it's not scalable. It's hard to have a dictionary updated. So we can do another things. We can do automatically this on the web. We can do this project, Wikipedia, and to invite everybody to collaborate with us. This is scalable. Really, the quality can be hardened because you leave everybody to collaborate, but there is some editor supervision. There is a hierarchy that says, hey, you don't have to do that. I say for many years to my students, try to edit in the Wikipedia. And many of them, they said that I don't have the qualification. Or they say that I don't know what I was talking, something like that. And there is some criteria to prevent this misinformation or spammers or whatever. But for instance, you have to say always reputed sources to the facts that you are saying. You say that in this war died this number of people. You have to say this. I read this in this source. If you don't do that, the supervisor is not going to validate your text. So, but there is problem because not all the supervisors are so prudent, so reliable. So there was a new project that said, well, maybe the Teams Partner Lead is a good idea, is to translate all the Wikipedia to a database with RDF. This is called DBpedia. They tried at the beginning to do by hand. It was impossible, and they said, "Well, there is a way to do the things that is web scraping that you say in Python with beautiful soup and these libraries. You have to read this, and you have to save this information in this way. If they say Shakespeare is born in." I don't remember, but upon a fable, even of something like that, you collect this sentence and put in the database. The problem is that there are many typos. There are many Wikipedia entries that are wrong. There are problems with the software because maybe the sentence is not clear. As I said, if the text is not clear, you have problems later. And more problems when you want to automatize this information. So it appears another project that is Wikidata. It's DBpedia, but cleaner. And well, they try to clean everything, but and say, well, we are going to know if something makes sense with scalable, with some authors that say, well, I read this tripod in this place and this place. Problem, it's not scalable. So in this case, the problem with dictionaries are that they are not scalable. And here we have the same problem again. Uh, well, and now we have ontologies. What I mean ontologies is another way is to deal with information, but in this case, the goal is artificial intelligence to have inferences, to have reasoning. In this case, we have many rules to do that. And the good thing, as I said, is the inference. There are many types of ontologies, but in our case, there are two that are more interesting. That is upper ontologies. Upper ontologies is the same approach that tries with software reuse many years ago. If we use the top part, the more abstract part of a project, we can reuse. This is a top ontologies. And there is another that is common ontologies. This is the second approach. We can reuse libraries. We can reuse small things. In common ontologies, they say, well, we can reuse things that are going to appear in every ontology that you do in the future. For instance, there is one that is meteorology that is about units of time. There are other for currencies. There are other, and you can reuse these bricks again and again. In this case, the reuse is better in this layer. Now we are in the era of large language models. Sorry. I don't know. Here is okay. Well, in this case, we have a good relationship between ontologies and large language models. Why? Because large language models can help to detect inconsistencies, can help to collect description, to collect data. But we need ontologies. Why? Because happens the same that happens with Wikipedia with Wikipedia to Wikipedia. If you automatize something, you are going to have maybe a 10% or a 5% of failures in this process. And ontologies also usually are validated by hand. You have reasonings, you have inference, so you can detect these inconsistencies and this need of explicability in the artificial intelligence models with ontologies. So the relationship between them is incredible. Is more is this well, again more scalable. but anyway, it's a good way to do the thing because we, for instance, look this ChatGPT. If you want 5 minutes, so okay. With ChatGPT, we know that if you want to explain something to a familiar, to your relatives, to a friend, if you know what this person knows about engineering or this person knows about biology, it's easier if you connect with his mindset to explain things that if you try to use your own words. It's impossible. Well, I'm biologist. I don't have to translate my words to your knowledge that is in engineering. What? This doesn't make sense. You have to adapt to the audience. And you can do that automatically with ChatGPT. Look, in this case, I said that to explain the concept of mutation in genetics from the point of view of a biomedical researcher. Is this? They talk with very special terms like nucleotide sequence. But now I said, no, explain mutation biology, mutation to an industrial engineer. And use his vocabulary or her vocabulary. And he said, well, you have a blueprint of the system, you can have a failure, and this can be neutral because many things that you change in a machine doesn't have any effect. Maybe with instead of this if debrock, this is again working. It can be beneficial or harmless. So it's interesting to use. Even I mean, to a student all the time, I teach Python, and I always said you have to use ChatGPT, but not for the assignment. To learn is the best tool ever because it's very specific of this person, the answer. Okay, but is ChatGPT as good as it seems? Well, I'm going to show this example because it's not conflicting with any idea that you can have because it's where Avila city in Spain is how many meters is above the sea level. So nobody's going to be curious about this concept. And I said, well, list the 5 highest cities in Europe with over 25-year ground resident or above 1,000 meters of altitude. Exclude holiday resorts and provide population and altitude in a table. Well, we have this. They said only there are two places in all Europe. This is ChatGPT. 2 places. They said we have one in Portugal, another one in Switzerland. Okay. And yes, it's about 25,000 and above 1,000 meters. But well, I said, well, try with instead of 25,000, try with 20,000. And they said, now there are 4, but many of them have more than this not that small. This small one have more than 20. Why we don't have this in this table? We don't know. But now I go to Gemini and I said the same from. And they said, well, you have Soria. Where's Soria there? Because it has more than 1,000. But we don't have Smolian. Why don't have Smolian here? Well, we can try in perplexity. I do the same in perplexity and they said, there are 5. There are 5, yeah. Is Avila, Soria, Guarda, Smolian, and San Giovanni in Fiore. Where Italy? Where is Italy in the rest of the list? Because the problem is very clear. It's not something that you say, well, you can consider sustainability like this or like that. This is not. It's not ambiguous. It's very clear. And I said, but Segovia, why is not Segovia here? Because it's not here, but it said in perplexity that is more, that is meet the criteria. So it's not as good as this thing. But when you see in table, it looks that it makes sense, but not always. And how I can verify this information? Well, there are many ways. For example, this voting system is better. Expert system, but expert system have a problem with scalability because there are not many volunteers expert in a domains. There is crowdsourcing is to us to do this, or in ChatGPT we have this time in this way or this way to say that you like the answer. Conclusion. Well, we have these problems with complexity and simplicity, or abstraction and concreteness and quality and scalability that you are going to have in any solution you can think. You are going to have all these problems and are very difficult to to deal with it. But now we have an opportunity. The opportunity is the large language models. Large language models are part of a solution, but it's not all, because we need this expert, we need these ontologies to interact in both ways, to do the ontology and to validate the facts. So these are the most promising, from my point of view, approaches. These common ontologies, this way to populate ontologies. And this is all. Thank you for your patience.
So thank you very much, Jorge. So we can discuss his talk maybe in the coffee, because Maria Carla supposed to have only right now, but she was saying that she was having some problems. Do you have a good connection now? Is it fine, Jorge, if we discuss in the coffee?
Yeah.
So there's a lot to discuss.